Hey everybody, welcome back to the channel. Today's video it's kind of a part two. In our last video, it was how to gash an end mill, and I'll put that video wherever it fits at the end of this video in case you want to check that out. But I thought it was important that we talk about doing the ends of a 2-flute slot drill because it's an entirely different gashing process. There's no plunging at all. In the last video, the gashing of end mills, it basically, that same set of steps works for the 3-flute, 4-flute, 6-flute, 8-flute, whatever you have. The only main difference is going to be the shape of the wheel. But with the 2-flute, there's no plunging or gashing as such at all. The middle step of the 3 steps is entirely different than it is on the end mill with multiple flutes. We normally try and put out one video a week. We know we're pretty busy with full-time jobs and just life in general, but I thought it was important that we get this video to you guys a little quicker before someone tried to use the last video to work on a 2-flute slot drill, and I'm pretty sure you wouldn't be happy with the results. Here's a slot drill that we're working on today, and it's actually in decent shape on the sides. It'll still cut fine, but these corners are in really rough shape, and they're not going to be happy cutting at all. So what we're going to do is we're going to repair the end of this 2-flute slot drill today, and I'll show you what our first setup is over here. So before we get started with our setups, let's take a look at how this thing is actually set up. So there's a 7.5 degree primary clearance angle here coming back from the leading edge. Then there's a 15 degree secondary clearance angle here. And then there's another clearance angle here of 3 degrees. The reason that's there is so that the outsides of the end will touch the workpiece, but the whole rest of it has clearance and won't be dragging along. Then we come to basically a 45 degree cutaway section here. And I refuse to call it a gash because there's no plunging involved, but this is a big part of what is going to make this thing be able to drill. For the first setup, I have my slot drill in my motorized workhead. It's being held in a 5C collet. I've got the workhead offset to 3 degrees. That's because we're going to use that to start roughing out the 3 degree clearance angle across the end of the slot drill. I do have my spindle on the machine dialed in true to the table, and I also have it at exactly the center height of this fixture, and that's super important because 3 degrees, although it's a small angle, it's still an angle, and so center is all critical. I'm going to be plunging straight in with this at the 3 degree mark, and I'm going to be adjusting my table until I see I'm leaving the tiniest little sharp little point right here in the middle, and then we'll be able to use that later as we progress. Basically, the little point I'm going to leave here is going to act as like a witness sight so that I know exactly where the center of the tool is, and that is going to be important in a later setup. So let's get right into it and start blasting back this damage. There's that setup done. You can see all this damage that used to be at the end is gone, and it has left us with an end that would not drill through toilet paper. And so we're going to get into the next setup here. So that's my first setup done. I've tore that down. I don't think anyone wants to watch me sit there and play with nuts and bolts. So the next 2 processes are going to be done in my sensitive workhead. So I'm going to get that off the shelf now and get it up here. This next setup relies heavily on having complete control over center height. So I need this axis of the sensitive workhead to be perfect, or as perfect as I can get it, close as I can get it. And in order to get this bang on, I first have to get this bang on. And so I've gone ahead, I've done that. I'm happy with that. Now I'm going to rearrange my dial. I'm going to get this running true this way. And you'll see in just a minute here why that matters. There's that one dialed in. Nice 0 all the way. So that'll work. Now that we know our tool is exactly, its center line is exactly at center height, all the way from one end to the other. That's why we were so careful dialing that in. Now I'm going to use my height gauge to indicate off the tool. So I'm going right off the shank here, touching right off on the shank, setting my 0. Now a little quick math, and I'll get this up to center height. Now I have this surface at my center height, and my tool is currently snug but loose in my collet. Just as a quick reference here, you can see how the top of this surface aligns with the center of the little tip we've left there. Now I'm going to rotate this tip, this corner, down onto that surface carefully and gently as best I can. I do have a 0 set here so I can check this. Now I'm going to tighten my collet. Now I'm going to come back and see if anything moved on me or if we're good to carry on. Yeah, so I'm pretty happy with that. We're still pretty much bang on 0. Had that been out, I could have adjusted this little micrometer knob here and rotated this in a controlled manner. The reason I inverted this is because now I'm going to use that to touch off to the bottom of my wheel, because I also want my wheel at center height. So that's what we're going to do next. I'm just going to come down ever so slowly until I hear it starting to touch. Okay, so we're just touching. Next thing I'm going to do is I'm going to swing this out to the 45-degree position, and we can start creating the thing with no name that is not a gash. This 45-degree angle is just a rough set. This isn't crazy critical. Now I have the bottom of my wheel set at the center height of the machine, and I'm going to set a 0 on my hand wheel that raises and lowers this, and I'm going to start out by roughing this thing out about 5 thou above center, and that way, well, we'll see as we go here, but this is where I'm going to use my little point here as a reference, because I want one of these lips to go well past center, and I want the other lip to stop well shy of center. The bottom of this wheel is going to wear in, it's going to wear out some, therefore its height will change. So we're going to do a roughing and then come back and do a finishing process here. There's side 1 roughed out, we're well past center, and now I'm going to spin this thing 180 degrees and we'll start roughing the other side in. There's the second side roughed out, and you can see I've stopped well shy of my center point, and that's because I want this to be my drilling tooth, and it needs to go all the way to, and in fact, a little past center. So now I know I've roughed this down. I'm assuming my wheel has worn some. Before I started cutting here, I did move my wheel 5 thou above center. So in theory, this little bit left between here should be 10 thou plus whatever wheel wear there's been. So what I'm going to do is I'm going to start by going to my first side again. I'm going to come down until I just touch where I first touched in the beginning. I'm going to note how far I have to come down with my wheel head until I touch, and that should help me determine how much wheel wear there is. And I'll do a little quick math and see if the wheel wear adds up to the 5 thou I was above center to start with. And I hope that makes sense. So there I've just touched, and I had to come down 3/1000ths of an inch to touch, or approximately 0.7075 of a millimeter. That's all roughed out. Now I'm going to come down the final little bit, and we're going to finish this thing up. Both tooth faces are now exactly on center. The only reason there's material here is because it's so thin that it's been getting pushed out of the way as the grinding's happening. But if you watch, I can just easily just break that. Now I can't break it right to the edges because there's a radius here and there's a radius here that the grinding wheel is left behind, but that's fine. We're just gonna hand bomb that out of there later, and I'll show you that. But for now, it's time to move on to our last setup. So now I'm setting the 3-degree angle in this direction. and the 7.5 degree angle in this direction for our primary. All right, so we're all set up to put our primary and secondary clearance angles on the end of this. The big reason I need this space between the end of the one tooth and the end of the other tooth is I need somewhere to run my grinding wheel off into, so I'm not putting a reverse angle on the tooth across the way here. I've got the first side rough down, so now I'm going to set myself a 0, and I'm going to bring the second side up to the same place. Now I just need to finish this up. I'm going to alternate from side to side, so I'll feed in a little, and then I'll do one side, then I'll do the other side. I'll keep going until I've removed any witness of the work we did with the motorized workhead. There's the primary clearance angles done, and you can see there's no longer any witness of that flat end that used to be on there. So I'm going to come up to my 15-degree secondary angle, readjust the height of my wheel, and then we'll finish those clearances. First side's rough down. Again, I'm going to set a 0, bring the other side up to the same point, and then we'll finish them both together the same as we did with the primary clearance. So that's our secondary clearance angle done. Let's pull this guy out of here. We can take a closer look. So this would work just fine as is. This tooth face, both tooth faces are perfectly on center. This one passes through center and a little beyond, so that's what allows it to drill. Now you could use it just as is, but because of these radiuses here, you have these sort of delicate little corners that taper from something down to nothing. And the reason I'm going to get rid of those is because I wouldn't want those little bits breaking off and interacting with all the other cutting edges. So because it's really not a critical step, I'm just going to get the appropriate wheel and hand bomb that out of there so that those edges are sturdy and not so delicate. Just going to come in here as carefully as possible and just get rid of that little web. On both sides. That's not gorgeous, but it certainly does the trick. We've got a nice clean notch in there now, and we have nice sturdy edges in here. Nothing's going to be crumbling off. You can tell it was done by hand. It's not perfect, but in my mind, it wasn't worth the time to do an entire setup to do that by machine. So that's why I do them by hand. Well, that's it for today's video, guys. I hope you enjoyed, and if you are enjoying the videos, and if you're looking for a way to support the channel, we now have a new button down below there. It's the thanks button. So if you're interested, check that out. It really helps us out a bunch, and we appreciate it. So thanks for watching. Bye for now.